Okay, I'm messing this question up. Right, this is the higher level 2019 paper question 12 part D. The first question was to do with the two types of hadrons that exist. And they are baryons, which are made of three quarks, and mesons, which are made up of a quark and an antiquark. Okay, there are such thing as hadrons, which are antiparticles, or sorry, baryons, which are antiparticles as well, and they'd be made up of three antiquarks, like the antiproton, for example, or the antineutron. The second part of the question was why does the pion have to be neutral after the collision? Well, we had two protons colliding, and we get two protons and a pion. So there's two pluses beforehand. We have to have two pluses afterwards because of conservation of charge. So that's why it has to be neutral, because we can only have two pluses afterwards. So the answer is to ensure the conservation of charge. Okay, the bit that I messed up was the kinetic energy question. So we know we're asked to find out the kinetic energy of the three particles after the collision. Okay, so what we're going to use here is conservation of momentum, essentially. That, like, conservation of energy, not momentum, energy, sorry. That we have the total kinetic energy before has to be equal to the total energy before has to equal to the total energy afterwards. And the only thing that's happening is that the pion is being produced. So we have a proton smashing into a proton, that's before, and then afterwards we have a proton flying away and a proton flying away, but also this pion flying away as well. And whatever energy is here has to equal the energy here. So we're going to have some kinetic energy beforehand, and then we're going to have the some amount of kinetic energy, but we've got to include the energy of the mass of the pion as well. Okay, yeah, Grant. Whatever energy is required to make that happen. All right. Okay, so right, we have the kinetic energy beforehand is a half mv squared, all right, for each of the protons. So it's the mass of the proton times the velocity that they're traveling at, which is 0.9 the speed of light. Okay, if I have two of them, I've got two halves, then the total kinetic energy is just going to be so I'm just going to call it E for the before energy. It's just going to be the mass of the proton times the velocity they're traveling at squared, which is 0.9 the speed of light. Okay, the mass of a proton is 1.6726 by 10 to the negative 27. Then we're going to multiply that by 0.9 times the speed of light. 3 by 10 to the 8, or 2.9979 by 10 to the 8 if we're going by the log tables. I got those masses from the log tables, by the way. Okay. Yeah, we could have used 3 by 10 to the 8. I was looking at the marking scheme. I don't know why. 3 by 10 to the 8 should be fine here. Don't forget to square that. Okay. I've lost my calculator. Okay, calculator time. So I have 1.6726 by 10 to the negative 27 for the mass of the proton. And then I'm going to multiply that by 0.9 times, I'm just going to use 3 by 10 to the 8. There's no reason not to. I know I wrote down the other thing there, but let's ignore that for the moment. Okay, so what we have here is 1.219 by 10 to the negative 10. What's that? Joules. Okay, now we know that some of that energy got used up to make the pion. Okay, so how much energy is the pion taking up? Well, it's mc squared. We go to the log tables and we find out that the pion has 264 times the mass of a electron. Okay, that's what it says. So we got 264 as our multiplying factor, then times the mass of the electron. So it's bigger than an electron. And from the log tables, we get the 9.1 by 10 to the negative 31 kgs. E equals mc c squared. So I'm just going back to 3 by 10 to the 8. I'm more comfortable with that. Okay, so we go 264 by 9.1094 by 10 to the negative 31 times 3 by 10 to the 8 squared. And we get 2.16 by 10 to the negative 11 joules. So that's the energy that is equivalent to 1 pion. Okay? So this is the energy that got removed in our collision to make the pion. So the kinetic energy afterwards is just going to be the difference between kinetic energy before and what got taken out of it. Okay, so the energy after is going to be 1.219 by 10 to the negative 10 minus 2.16 by 10 to the negative 11. By 10 to the negative 10 minus 2.16 by 10 to the negative 11. That gives me an answer of 1.00 by 10 to the negative 10 joules. We're still, oh, sorry. 1.00 by 10 to the negative 10 joules.